after giving a small introduction.
Yeah, sure, ma'am. Sure. Yeah.
Yes, ma'am. So, dear participants, I welcome you for the second session. In this session, we are having the Dr. Priyadarshini ma'am with us. So, it is a great privilege to introduce an accomplished academician, researchers, and mentor, Dr. R. Priyadarshini Rajaram. With over 22 years of experience in teaching and research, she currently serves as a lecturer and program director for applied data science at Cardiff Metropolitan University, UK. Her research expertise lies in artificial intelligence, data science, and medical image analysis. With over 40 research papers published in international journals and conferences, along with 5 book chapters in Springer and Elsevier. Dr. Priyadarshini has received several prestigious accolades, including the Best Project Award from TNSEST 2017, Outstanding Woman in Computer Science Award by Venus Foundation 2018, and the Outstanding Researcher Award from SBITE Educational and Research Foundation in the year of 2020. She is a review panel member for a reputed journals like IET, Image Processing, and International Journal of Computing, and has served as a session chair in multiple international conferences and symposiums. As a passionate educator, she has delivered invite talks, keynote addresses, and hands-on workshops on AI, machine learning, IoT, and big data analytics, bridging the gap between academia and industry. With her vast knowledge and commitment to the technological advancements, we are honored to have with us today. So, dear participants, please join me in welcoming Dr. Priyadarshini for our today's session. Thank you, ma'am. Welcome to the session, ma'am.
Yeah, thank you. Thank you, Dr. Malati, ma'am. Let me quickly set my device. Yeah. So, thank you for introducing me, and it's really, a great. It's my great pleasure in joining you all today. I'm glad to be part of this Atal Fdp program, and thank you for, the great opportunity. So, I would like to thank the organizers, Dr. Malati, and the team behind this wonderful initiative, and. Yeah, thank you so much. And let me quickly introduce myself. And I'm Dr. Priyadarshini Rajaram. And as Dr. Malathi introduced me, as I'm currently working as a lecturer and program director at a School of Technologies in Cardiff Metropolitan University. And my research interest, it focused towards applying the AI technologies in healthcare. Especially towards advancing the early diagnostics. So coming up with AI-driven diagnostic tools for diagnosing the disease early. So this is my current focus in my research works. And maybe with that note, I'm really happy to be a part of this session to just share my my experiences in my previous projects and how I come along and how I am into the in the proposed area and all that. And so I'm taking this platform to share my experiences with you all, and I'm happy to have open discussions around. If you I heard I think people from diverse disciplines, right? I think even not only computer science, I heard. So people from diverse disciplinary areas are are participating in the session, and also I heard research scholars also participating in the session. So after briefing my my session content, I'm happy to have any open discussions if you'd like to have towards maybe if you're working on any specific healthcare related projects. I'm happy to have the open discussion towards the end of the session. So maybe with that note, I would like to share my screen. Okay, I'm going to share my screen. At any point, if you find any technical difficulty, like if you couldn't see my screen, or if you couldn't see hear me, or any technical difficulties, please let me know so that I can. You can unmute and tell me so that I can come back and sort that out. All right. So and yeah, I'm going to start sharing my screen. I'm just going to take you to my slides. I'm just going to minimize all the steps. Keep this down so that, right. So hope my screen, is my screen visible,
Yes, ma'am,
Dr.
visible.
Malati?
Make it,
All right,
yes,
all
ma'am,
right.
visible.
All
Make
right,
it
thank you.
full screen, ma'am.
Yeah, all right,
Yes,
thank you.
yes, ma'am.
Thank you. All right. So, so this is the topic for today's session. So I'm going to discuss about how literally we can make use of this AI big data technology for developing improved healthcare solutions by leveraging the large data sets. So this is the topic for this particular session. And maybe to start with, because when I say AI and big data technologies, if we look into the current context, so these two technologies, AI and big data, it plays a vital role towards transforming the current healthcare systems. Because with these technologies, because the healthcare practitioners are able to do data-driven decision making. So that data-driven decision making, it really helps them to improve the patient outcomes. It helps them to improve the population health. It helps the healthcare practitioners to monitor the individuals who are under care. So that is really the real focus of these technologies. So when there was a because the visual you could see here in this slide, if you could this was the result from one of the survey conducted to the healthcare industry professionals. So they were asked this particular question, like, which technologies would you like to invest in the next 2 years? So this was the question asked to the healthcare industry professionals. And if you could see from the results of this survey, you could see 50% of the healthcare professionals, they have mentioned AI, they have chosen AI. And if you could see the next 38% of people have given big data, and the rest of the technologies is just falling down the line, right? So this is also, this visual is also, this survey result is also evidencing that these two technologies really they are reshaping the healthcare sector. So now, okay, maybe with that note, I'd like to go on further with a particular topic. For example, when I say AI, because I think a couple of sessions has been covered. I think you had a session early, I think yesterday, if I'm not wrong. So you had a session on AI machine learning technologies for healthcare. So since that session has been covered, I'm not going to go into detail. Obviously, I can just give a quick recap on. I can just proceed with my content. So obviously, this AI technology, it relies on the big data. Right. So because obviously the AI technology has the ability to discover useful insights, or this AI technology is having the ability to discover the disease patterns, right? All it can do, but all it does is it relies on the data. So that is the that's the crucial part, right? So this AI technology, it relies on the big data. So when I say big data, maybe this could have been covered in your earlier sessions, but I would like to quickly touch upon that, right? When I say big data, right? Because when we look into the healthcare data, because our focus of discussion is only around healthcare data today. So I would like to fix my discussions also around healthcare data sets. So when we say the big data in healthcare, right? So the data, as we all know, the data, initially the data we were using were very well structured. And sorry about that. Okay, so the data were very well structured. Then what happened is over time, after the introduction of the internet and the social media platforms, the data has become unstructured. Even in healthcare, the same happened. So the data started coming in unstructured formats, right? So the data is both structured and the unstructured. So we were not able to deal with the unstructured data, right, with the traditional tools. So that's why the AI technology came into picture, and like the AI technology is able to even deal with that unstructured data, right? So it's able to get useful insights out of the data. That's how AI came into picture. So maybe, so when I say that the type of data in healthcare, right? So maybe the data obviously which we could see in the real time, right? So with the data, right? The data, the characterizing the individual's health characteristics, right? So the data, either it might be in the form of electronic health records, right? Like, the lab test reports, or the patient histories, or right, so, or and if there are any outcomes from the test results. So all, I would say the clinical notes and the lab reports, they all will come under the electronic health records category. So that is one form of data, right? So all we need to discover is, we need to discover some useful key insights, the key healthcare parameters from these lab reports and the clinical notes. We want to get that insights automatically. We want a tool that could automatically extract these key insights out of the data, which would be helpful for the healthcare practitioner to to go with further analysis and decision making. So that is EHRs. The second source is obviously, I would say, the medical imaging, because the data, it not only exists in the form of an electronic health record, right? And also your data, it also exists in the form of images, the medical images, right? So as we could see in the real time, x-rays, MRIs, right? Or a CT scan, or a pathology slides, or you could say ultrasound. There are different types of imaging modalities exist. So even that data is also used by the doctors or the healthcare practitioners. So what they do is, so the doctors, they will look into the report, because they are having the domain expertise. So they look into the report, they analyze, they detect the patterns. They'll detect the patterns which is characterizing the particular disease, and they just share their treatment plan. So now AI is coming in picture. What's happening is, so AI is now, the AI technologies has been used as a clinical decision support system, or it is these tools which are upcoming. So these tools are acting as an aid for the doctors, right? For at this era, at this context, it's not replacing the doctors, but these tools, these AI driven diagnostic tools, are they are acting as clinical decision support systems, or they are acting as an supportive aid for the doctors to proceed with their further analysis and decision making. So now, so the same thing we can do. So we can, in terms of when we work with the medical images, what we do is, we take these data, obviously, we can make use of the AI technologies. So right now, it means obviously, when I say AI, when I mention AI technologies, machine learning, deep learning, all that technologies could be utilized, right? And we and we can discover the disease patterns automatically from these imaging data, right? So the medical imaging is another source of big source of data in healthcare. And also, if you look into the into the current context now, the wearable technologies, right? So we started using the wearable technologies, right? So in the form of a Fitbits, right? So using which literally these wearable technologies are really integrated with the mobile health technologies. So now I would say AI, I would say this is a current context which is really which is very trending and popular. Lot of research and potential scope and opportunities exist with this AI wearable and the mobile health technologies. So this is the current context. So because obviously with the wearable, we can gather the individual's healthcare parameters, okay, and that could be analyzed with the AI technology, and then the further notifications and the recommendations could be sent over through the mobile app to the individual. To maybe it could be used for self monitoring, or to understand the current context, or the status of an individual, right? Suppose if the individual is under care, kind of that. So this is also this wearable technology, this wearable device is also another source of big data, right? So using which we gather a lot of healthcare parameters, like about the individuals, right? Maybe I would say, like if they are involved in physical activities. Even the Fitbits is giving us a lot of insights, right? The apps, the Fitbit, through the Fitbit apps, we could see the, like the insights, right? How many steps we walked. So we're getting all that, right? So this is also another source of big data, I would say. And obviously, like the genomics, the genomic data, right? The genetic data, right? So maybe with the genetic data, obviously we can get the complete we can get the complete genetic sequence, and maybe we can discover some biomarkers, like what is the risks involved, genetic risks involved with a particular individual. Maybe that could be discovered from the data, genetic data, right? Kind of that, right? So there are many more. I just brought some sample data sources. So our AI technology, so it relies on these data sources, right? So, and then obviously when we have the data, we can use AI, and AI can get the it can recognize the disease patterns or the key insights from the data which is needed for the healthcare practitioners. So this is the context of the proposed theme, AI and big data for healthcare. To move on, when I just briefly mentioned with my previous slide. So when I say the key technologies or the key AI techniques, right? So obviously, I would mention these, like machine learning, deep learning, right, and NLP, natural language processing, and also the big data platform. So I would say these four. So obviously, as I just to quickly recap, which was covered already for you, right? So what we can do is, when we have a data, what we can do is, so we can come up with the novel machine learning or a deep learning algorithm, okay? And that algorithm could be customized according to the data what we have in hand, okay? And then so we can build a more, like with the training data set, we can build a customized AI model, and that AI model could do the predictions, right? So it could do the disease predictions, kind of that, right? So that's what. So these machine learning and deep learning algorithms could be used mostly it is used for predictive analytics. Hope that has been covered, right? So predictive analytics, predicting the disease patterns in advance, right? And getting some insights around that predictions, okay? And obviously, because your data is unstructured, your data is available in the form of a clinical notes and all that, right? So this NLP technology plays a vital role. So a lot of NLP tools widely used, to discover the insights from the clinical unstructured clinical notes. Okay, and the last technique is big data platforms, because when I speak about these data sets, so which when obviously even this could have come in your earlier discussions too, when we deal with the data, right? Because I mentioned your AI model you develop, right? The accuracy of the model, it relies on the data we feed in, or the data we use to train the model, right? So the accuracy depends upon the data we supply, right? So how well we are supplying the data. When I say how well we are supplying, right? So the data I feed in, right? So I should have enough samples, okay? The data I'm supplying to train a model, okay? It should be more diverse, and it should include all demographic features. I'll speak about that over slides, but at this point I would say that the accuracy of the AI model, it relies on the data we feed in. So when you formulate your training data set, right, obviously your data set should be diverse enough. It should cover all. You should have enough samples across different categories of data what you have in your current work, and it should be more diverse. It should be very inclusive. Okay, I'll speak about all that over slides. Okay, so when we try to incorporate these aspects into a data, obviously if I look into the size of the data, obviously it's going to be huge, right? And so it becomes a big data. The data is becoming huge, obviously. We need to make use of these big data platforms, right? So, like Hadoop, Hive, all that. So yeah, or AWS, or which is recently AWS and the Google BigQuery. So these are all the the platforms, big data platforms, where we started because the data is, because, especially since we started using this wearable technologies, these wearable technologies are integrated. So and the sensors, the advancements in the sensor technologies, I would say IoT and sensor technologies, right? So because the data is becoming huge, voluminous, so obviously we cannot rely on the local servers. So obviously we have to move on to cloud, right? So and so where we can just to put all your data, all the your data can be stored there, and further obviously we can run the our algorithms with the data in the cloud, and then we can get insights, and that can be disseminated to the healthcare practitioners or the hospital or the nurses, whoever is involved in taking care of the individual kind of that. So so that is the need of these big data platforms. So we need to make use of these platforms to store our huge data, real-time data, right? So these are all the technologies. Okay, and no, I've just got one slide you could see here, right? So I'm just moving this still further. Okay. So if you could see here, you can I've just made a summary of what all the AI technologies which could be used. Just if you could see here what AI technologies could be used. So you could see your machine learning, right? Basically your deep learning is a family of we have, maybe this could have been covered. When I say machine learning, there are a lot of algorithms, machine learning algorithms exist where with a training data set, we can we can train the train a machine learning model, and that can do, the model can do the predictions, right? So there are different algorithms SVM, Kane, and the different and neural network. From the neural network, over time, what happened is the family of algorithms got developed from this neural network. Initially it was one of the machine learning algorithm, and then over the time, so under the neural network, the family of branch of algorithms got created, so they become the deep learning algorithms, right? So this is the branch of algorithms, like machine learning, deep learning algorithms, which is different types. Maybe this could have been covered, like supervised, unsupervised, and all that. Okay, and then obviously this is one branch of AI technologies. NLP, as I mentioned, to work with the text to get the insights from the clinical notes. Okay, and I would say this is second stream of the AI technologies. And obviously expert systems also, we can develop expert systems with AI, which can act as a clinical decision support system. Okay, and also I would say computer vision, right? So where we deal with the images, medical, for example, in healthcare, when we deal with the medical images, right? So and we discover the patterns out of it. That's called computer vision, okay, or image recognition or machine vision, we call it, recognizing the disease patterns from the medical images and also from the speech samples. And also even AI is getting more diverse. Okay, it's also used in planning, scheduling the patient appointments, and also AI is clubbing up with robotics technology, AI and robotics, even doing the, so I mean the robotic aided surgeries are in place here. So all that it happens. So this is the wide picture saying the AI technologies, especially for healthcare data analytics. Okay, now that's about it. So, and then I just got some few articles from literature. This is one article I found from the literature where you could see, for example, if we have some clinical records. So from the clinical records, we can get the key insights with the NLP technique, and those key insights, right? The electronic medical records or the image or genetic data. So from the data, okay, from the discovered data, further we can use machine learning or deep learning technologies, and we can get the useful insights out of the data with the AI machine learning technologies. So just a summary or essence of content from the article. For example, machine learning, mostly it helps for structured data. obviously, your deep learning, it helps with unstructured data, right? So all that, I mean, obviously it helps in really improving the patient health. This was the summary, and this is another article I found from the literature, where, because at the one I mentioned, right, like using the wearable technology. So we are using the wearable technology. We are getting the live stream. We are getting the data from the real time, and so the data that we could do the real time monitoring of individuals, and obviously, if that, and we can do the treat, we can monitor the patients, I mean, the current health status, and maybe the ECG level, right? So the respiratory rates or the heart rates, is there any variability? All that could be monitored live. Okay, even if needed, that could be connected with if the person is under care, maybe the wearable, it could be integrated with the clinical system, so that the individual could be monitored by the clinicians, right? So this is also one ongoing trending I mean, area of research. Okay, and yeah, as I mentioned, the key trends are doing predictive analytics as one key area of research, and where there are a lot of potential opportunities towards doing the predictive analytics. Because when I say predictive analytics, predictive analytics is detecting the disease early, detecting the disease patterns early, right? Obviously, if we look into the way how it helps the people, detecting the disease early, right? It helps, it improves the survival rates, right? And also it helps the doctors if we could detect it early, any disease, right? So it could help the doctor to do the treatment planning and to come up with more customized treatment plans, personalized recommendations towards a treatment plan, or a rehabilitation could be done, all that. So this really improves the patient outcomes, right? So that's how it plays a vital role, predictive analytics. And this is my focus of research, and I also work under under remote monitoring and wearable technology integration. That's what I just mentioned. We can remotely monitor the individuals with the help of this wearable and mobile technology integration. And obviously, this is also another key area of research in healthcare, like coming up with the personalized medicines based on their clinical data. So that's also another trending area of research. Right. So, and maybe these are the key trending aspects, where the research could be carried out. And also, I've not brought all the applications that are huge. I just brought few sample clinical applications. For example, if we have for example, we can do the one pathway could be we can do the AI powered imaging. We can make use of AI technologies, and from the medical images, we can discover the disease patterns. We can detect the disease patterns, and that would help the radiologists to act faster based on the detected insights or discovered insights. So that is one pathway. And obviously, you can do this predictive analytics with the data in hand. You can do some predictions, and you can do the further planning. For example, planning readmissions of patients who are under care. And obviously, drug discovery, with the AI, obviously you can analyze the clinical data, right? And based on their clinical trials, okay, developing the customized drugs, right? So all that. So these are all some sample applications. I would like to quickly give because my area of research and my expertise is around medical imaging. So I thought I can share my case study, one of my case study towards early diagnosis. So the case study here is early disease diagnosis using AI in medical imaging. So I've taken the specific case study as detection of the lung cancer. Towards this, so for example, this how generally we carry out the we work on every research project. For example, to brief about the case study and the scope of this particular case study, because when we say lung cancer, because that's one of the leading cause of death across the globe, right? So, and this need to be detected early. right? Because this obviously, as I mentioned, this early detection of that lung cancer, right, with the help of, if we could detect the pre-cancerous lesions with the AI technology, right? Obviously, that would help. Or that would really help the doctors to detect early, and and then maybe they can do the treatment planning or some. So that could obviously improve the survival rates of individuals, right? Obviously, because with the traditional techniques, it's because if you look into the current context with the traditional methods, which is time consuming, and obviously, like the like the like, because of it depends, because obviously the expertise, because I mean, because out like now when because the expertise of radiologists, it differs from person to person, right? So that is also there, in right. So because it will be time consuming sometimes, right? So that is the one of the limitation. And obviously, this AI powered medical imaging really would help in detecting the disease early, right, to improve the patient outcomes. So this is the scope of this particular work. Obviously, what we could do, how we can detect lung cancer, is when we look at that particular like problem statement, right? What we can do is we can, yeah, because yes, for the radiologist is going to be time consuming, right? So like no, and there is a, like the expertise of the radiologist is it varies from person to person, and more labor intensive, time consuming manual processes are involved in, right, in the real time, right? So these are all the limitations. Now what we can do is, a solution could be, we can come up with an AI model, right? A machine learning or a deep learning model, right? So and that more, if we feed in the, like not like, if we have the enough training data, right, and if we could feed in that data, and if we build a model, and that model could detect those patterns from the images, right? Automatically, it could detect it could detect the cancerous lesions from the lungs if it's a CT image. So it could detect the cancerous, and it can classify. Okay, like no, it will take the model will take that. You need to supply the if you supply an image, right? So it will look for every pixel in the image, and it will categorize whether it is a cancerous or a non-cancerous lesion, kind of that. And finally, it will be able to tell you the, for example, what type of cancer the particular sample is having, kind of that, right? Sample images having like that. Okay, so we can make use of these machine learning, deep learning models. We can build models, and obviously this is one pathway. And obviously, suppose if we have the clinical reports of the patients, right? So we can use NLP to extract the key insights from the clinical reports of the particular patient. And obviously we can in terms of the data, I would say, so initially, for example, generally how we carry out is, if you're just starting a new area of research, for example, if you're starting with for example, if you're starting if you're into you're looking into this particular application, for example, lung cancer, detecting lung cancer early. So how you can start with this, maybe this might be helpful for the research scholars. What you can do is, I mean, as I think that this point could have been covered in your earlier sessions too. There are, couple of benchmark data sets available for research purpose. Okay, right? And obviously, which are available, which are you most of the, I have a couple of links I'll be sharing towards the end of the slide. I've added a slide also. So what you can do is, for example, most of the data sets will be available for research purpose in the public domain. Okay, you could find some, but even if there are some data sets, okay, but which you find which is relevant to your context, which might help your work, if you feel, if it is not accessible but in the public domain, but most of the repositories, there will be some process behind where we just need to give our request and the details about our project and what you're looking for, what we are looking for. If you say that, maybe if they look into our request, right, they look into our application, and then if it is a valid thing and authentic, then they'll most probably they'll approve it, and you will get access to your data. right? So what we can do is, if you're starting, if you are at your early career stage, maybe you can start, or if you're your early research phase, okay, maybe what we can do, what you can do is, you can take some benchmark data sets which is available in the public domain, okay, and then using that benchmark data set, what you can do is, you can you can build your models, okay, your AI models with either machine learning or deep learning. Okay, you can build models and you can just check your accuracy, and further you can refine it, and all that you can do basically. Okay, so for example, maybe like I just brought one example for like for example, this particular case study, if you see, we need the lung CT images, right? You could see this, like there's one source for lungs where we can get the lung CT images, like no, this lung image consortium, it has the lung imaging data, right? So this, that could be used to train and validate the AI model. So this could be done. Okay, and if I say the like no, okay, like this is a solution. Now how I can carry out my work is, basically, first I have to gather the data. So for gathering the data, there are two pathways. So if you're at, like if you want to, like first you want to do some experimental work, you can do that with the sample data set available in the public domain. Right, and the other option is, suppose if you are going to get involved in a real-time project, what we need to do is, so we have to collaborate with the hospital. We need to have a healthcare practitioner, for example, for example, if you are involved in real time, if you are involved in real time projects. So in that case, if you have some idea, what we need to do is, we need to get collaborated with the hospitals. We need to bring a healthcare. We should, for example, if as faculty, if we are going to, if you are planning to do a research work, okay, as a research project, okay, and maybe if like maybe if we need some funding, obviously we go for the funding calls, right? We approach the funding agencies, right? So when we do that, so one thing I would suggest is, because because as researchers, because even I was in that state. As researchers, what we do is, we look into the literature and we analyze the gap, we figure out the limitations, and then we come up with an idea, we propose a methodology to address the gap. We do that. So in addition, for example, what we need to do is, we look into the literature. Also, what we else we need to do is, because we need to have a healthcare practitioner in our in the team, so that, because they are the one who's in practice, who's currently involved in the healthcare practice. So the healthcare practitioner will be able to, will be in an even better position to say, this is how we are dealing with, for example, this is how we are detecting the lung cancers. So, and we have these gaps, or we couldn't find these aspects from the images, or kind of that. So they will have literally they will have the problem statements with them. They will have the couple of requirements towards every application. So I would I really am, I appreciate that, because we should have the person in team, the healthcare practitioner in team. So, all right, so or a hospital with our team. So that what we can do is, when we work on real time projects, so we can have the person in team. And also, if the hospital, if you're bringing the hospitals or scan centers in the as part of the team, so we can they obviously with the, obviously we have to go with the proper ethical approval process. We have to go with the NDAs and all that. So when we go with the real time project, so what we can do is, so obviously we can also get the data from the hospitals, or the or the scan centers, with the proper NDAs and the ethical approval process, completing all the processes, we can get it. Okay, so that is also, I would say, so more for most of the research projects. So this pathway is really a very good one, which is really helping us to get the requirements from the doctors. And and obviously, since we are tied up with the hospitals, we could get the data from the hospitals, and then with that data, right, so we were able to work on and also we'll also get enough samples also across categories, covering the different demographics and all that. So we could get the enough data, so that further, what all we need to do is, we just need to do the process the data further and come up with a model to do the accurate predictions, kind of that. Okay, so sorry, I have gone with depth into towards collaboration aspect. So that's what basically in terms of implementing your implementation workflow, the first point would be like, all we need is, because to go further, all we need is the data, right? So where we can get the data, right? So either from hospital or through open source data sets, we need to look into that, okay, based on your context. So you have to get the data, so you can get the data. And then obviously when we take the data, maybe it might not be in a form which is like ready for analysis. Also, you need to do some pre-processing. You need to do some, for example, if it is an images, obviously there will be some noise present, right, in the images, right? So, or you might need to do some pre-processing, okay, and to further analyze, to further send it for like, training your AI model, right? So that's, so we like, after data collection, then you need to do the data pre-processing. And then after, like, you do your acquired pre-processing, okay, then you supply your training data set to build your model, okay, right? So your model, you can either use like, machine learning or deep learning. If you're using like, CNN and deep learning models, you can use a, for example, I'm saying you can use a CNN model. For example, you can build a model and that can like, detect the lung cancers. And further like, after building that model, maybe you can use further, like, to you, like, you can get the like, but you can obviously, when we develop the model, I would say before deployment, the model need to be validated. So you should have the, because when I say the healthcare practitioner, right, so it could be a doctor, or he or she could be a radiologist, based on the nature of work you do, whose expertise is needed to carry out the work. So accordingly, we need to have the person in the team. So like, obviously, so by having them in the team, obviously they will help us to, because our model is doing some predictions, right? And the model, it need to be validated, right? So like, how well the AI model, how well it has, like, how accurately it has diagnosed to the the disease labels or categories, okay. And so you need to have the, like, that need to be validated by the radiologist, okay. And then maybe like, further, based on the radiologist feedback, further you need to customize, and you have to bring that reinforcement learning there, and you have to come up with a better model based on the feedback. So once your model is fine, right? So it gives, it gives, when, for example, when it is accurate, when you feel it's accurate, right? So then what we can do is, like, this could be like, deployment. Deployment is like, for example, if you're coming up, like, this could be developed as a tool, right? AI-driven diagnostic tool, right? And this tool, it could be integrated. It need to be integrated into the radiology workflow, right? So that, because they'll be having a current system, right? They'll be having a system, a way to analyze a lung CT images, right? So whatever the tool we develop, it need to be integrated into their workflow, so that the radiologist can start using it, okay. So this would be, this is how the the workflow will be. For example, if we do a project with the medical images, with AI big data technologies, okay. So yeah, so in terms of the limitations, for example, in such work, right? The limitations would be, for example, one is one the, like, I would say, like, the first thing would be in terms of the quality of the data we get, right? Sometimes if you are like, because the quality of the CT image, it relies on, like, because there are different vendors and different CT machines, and how they get the image, and the quality of the image, that plays a vital role, right? So the data quality is one challenge. So obviously, how we can mitigate that is, we have to come up with a pre-processing algorithm. We have to, like, we should have mechanisms to pre-process and sort that issues in the data quality. That is one thing. And the second major issue is, when you go with the AI in healthcare, the bias, okay. Any thoughts around this term, bias? I would like to hear from the audience. And have you heard about this term, like bias in the training data?
Participants will note only, ma'am. They will put the questions or any doubts in chat
Oh,
box
they
only.
can't. Yeah,
Yes,
no,
ma'am.
okay.
Yes,
I'm going to.
if they will arise they will ask any doubts, I will read you, ma'am.
Okay, so
One
they
side
can't
data,
interact, ma'am.
one
They
side
can't
data.
interact. Oh.
If you want to, at the end of the session, we will interact, ma'am.
Oh, all right. Sorry about that. Okay, then it's fine. It's
Yes,
okay.
ma'am. But for your question, one participant has answered as one-side data
Yes.
values.
Sorry.
One-side
What is that,
data
ma'am?
values for
One side.
biasing. One-side data values having more frequency of one, like that.
Okay,
You refer
okay,
the
all right,
chat
okay,
box.
got it, ma'am, got it.
Yes, ma'am.
Thank you so much. Yeah, so maybe I'll brief on that because there's something we call it as bias because as one of the participant mentioned, yeah, that's like no just to like to give a more brief description about it. Bias is basically sometimes because for example, if I'm having a lung for example, if I'm going to build an AI model, okay, if I'm having an open source data set, okay, so for example, if there are some for example three categories of lung cancers, for example benign, malignant, and we have predefined categories of lung cancers, right? So the data set I'm holding, right, for example, if I'm having three categories of lung cancers, okay, right, so then okay, I should the I mean for example, I should have enough samples in my data set, okay, I should have enough samples in my data set characterizing, okay, or or demonstrating every category. For example, if I have three categories, okay, then for example, I should have, for example, okay, if I'm going for deep learning, obviously no, I should have like I should have enough samples. For example, I will say, for example, 1,000. For example, okay. So I should have, if I'm having like, if I say 1,000 images, so I should have 1,000 images representing category 1, 1,000 images representing category 2, 1,000 images representing category 3. Let's see if we have three category of lung cancers, right? So then in total, if I have like 3,000 images, so if I'm supplying that, then you mean my algorithm is not gonna be my model, the one I'm going to build, is not going to get I'm not going to get this bias issue, right? But sometimes in real time, or when we look into the open source data sets when we work with, right, so it might not be the case, right? So sometimes okay, I might have like more samples representing category 1 and less samples representing category 2, right? So this is one thing I would say. Then maybe I can give you another example, right? For example, for example, in terms of like the patient demographics, okay, right, sometimes I might have samples of like samples representing same age category. For example, if all samples are under 50 in the range, if all the samples in the data set, if they all fall only within the age limit like 50 to 55, right? So I'm not covering the broader range of like I should have samples across the different age groups, right? So that is also, I would say, some form of biasing, right? What I'm trying to say is, because this is one issue we encounter when we work with open source data. So sometimes there might be bias, that is we might not have enough samples representing every categories in the training data set. So this is one challenging thing, okay. And for example, obviously one solution could be, obviously now we started using this synthetic data, right? We started creating the synthetic data, right, from existing data. Like no, you can create the synthetic data, right? Or you can do data augmentation. We are doing with the existing data, and we are trying to build up our our samples. So we do that way. Okay, there is one more pathway, federated machine learning. Might be could have heard about it, right? Because for example, if I'm going, for example, if I'm developing an application, okay, if I'm developing a mobile application, like to monitor the heart condition, for example, or right, so when I'm going to do this one, okay, my app, it should work across population, right? Right, for example, obviously when I'm going to develop an app, I'm gonna just make it usable for the public, for the society. So when I'm developing an app, right, so like obviously the one, like obviously I should have the data, I should build a model, and that model should predict the heart disease condition, for example, right? In that case, so the data I feed in, right? The data I feed in, so there should not be any biases. Okay, so I should cover, like, no, my data. It should have enough samples across the different population demographics. Okay, I should have enough. I mean, when I say it could be like, when I say the demographic, like, no, equal, like, no, I mean. I should have equal demographics in the sense, like, I should have like, samples across different people from different countries, or people across different ethnic regions, or across age groups, getting it. So this is what we call it as like, the diverse data set. So we should have a diverse data set. When I say the data set is diverse, it means I should have samples representing the patients across the diverse, or across the different demographics. Okay, so when I do that, when I construct my data that way, or when I bring that diversity, or we also call here as like inclusivity. When I bring that inclusivity, when I so that, no, obviously, no, when I bring everything in, and when I feed into that, when I bring in every characteristics that demonstrate the particular disease pattern, right, across different population, when I do that, obviously, no, I'm trying to make my model more accurate. So whatever be the, like, the with the ethnic region, whatever be the age group, so my model is trying to give an accurate prediction towards when it is used, kind of that. So towards this perspective, there's one pathway that is like, no, maybe I thought I'll just highlight this also, because this is, I mean, we started using this federated machine learning. Hope you could have also, like, come across this one. So where, how, because initially early, like, how we were doing is like, no, so we will have our own data set, either from the hospital or from the open source. We just have it in our own workstation, and we just like, no, train it, build model. We do that way, like, we were doing that way, standalone we were doing. But now what happens is, like, after introduction of this particular technology with this federated machine learning, what we can do is, we have the option, because, obviously, if I'm going to, like, for example, if I want to develop a model, okay, right? So for example, if for example, if I'm going to develop a solution for India and UK, for example, right? So then what I need to have population represent from India, and I need to have a population from UK, right? So then I need to train a model, right? On edge devices, maybe in India. Then I need to train a model here in UK, and both the models will feed in, like, based on the feedback from both the model, I can create a global model, and that model could work for both the population, right? It can do the predictions for both the population accurately, kind of that. Okay, so that's how it's. I mean, that's how the pathway has been, like, moving forward towards. So, like, what we can do is, using this federated learning, so we can train the models on the local edge devices, okay, wherever the data resides, because the data is also an issue, right? So because accessing the data is also an issue, so we don't need to move the data at all. So the data, for example, if I'm developing a solution for India and UK, so if you have, like, with the data in India, right? So the model could be trained with the data from India, and here I can train my model with the data from UK, and then both the the model feedback could be retrieved, and it could be aggregated, and then it could be further sent to a centralized model, kind of that. Okay, so this is what so maybe this could be one solution. So I just said an example for Indo UK. So maybe, like, select, maybe we can do it. For example, if we look into the the health challenges, we have, like, global health challenges, like, because the diseases like heart disease, dementia, Parkinson's, most of the diseases, they are like, there are, because these diseases are affecting globally. We call it as, like, global health challenges, because which need to be addressed. So in that case, this is a very good pathway, I would say. This really helps us to work across, or beyond borders, right? Beyond borders, literally, we can connect, collaborate, and we can, like, jointly develop the solution. So that's the one. So that's why I thought I can introduce, I can just mention this at this platform. So this is one way. This would obviously help in reducing the biases. Okay, so that's about the case study. Okay, and I'm not sure. So can I do this one? So because I have this, I thought maybe I can do a quick demo. Because obviously, like, this is because, in terms of the fundamental concepts, this is what, like, this is about, like, for example, AI, big data, right? And about the technology, how it is used, what all the techniques are there, like what all the AI big data technologies, how these technologies are utilized for analyzing the healthcare data. All that has been, and key applications has been covered. And I just demonstrated a case study, how we can work on any healthcare project that has been covered. So can I do a quick demo? I can quickly show you, because when we do in terms of hands-on, because for example, if we want to analyze the data. Okay, so in terms of analyzing the data, I would say maybe the tools we commonly use, right? We use is like either, for example, if we would like to get some basic statistical insights from the data, right? We go for some data visualization tools like Tableau, or we can go for Power BI or Google Colab, all that. We can use any data visualization tool, or sometimes if you want to do some predictive analytics, so right, predictive modeling, we go with like, we use Jupyter notebooks and we do the Python scripts and all that we do, right? So I thought maybe I can quickly show you some hands-on around how we, for example, if there are any beginners or like who are just starting your research career, it might be helpful. I mean, can I proceed this one, or is it fine, ma'am? Or is it, or if everyone knows this, maybe I can, maybe I'll just quickly, I would like to gather participants' perspectives. So towards, if they are, if most of them are familiar, then maybe then I can just jump on to the next slide. But I want the participants, like, can you go to the Menti, like, which we use, right, generally to get the poll. So I've just created one question there, like menti.com. Can you go to menti.com and like, if you could share this code on the in menti.com, there will be a question. Like, just you can tell me like, like, are you familiar with the like these tools like Tableau or like, Python, all that. So I've just given a question array. Are you happy to like, uh, take the code 24269903? This is the code. Please note. And you can go to menti.com and you can type the code, and there is a question. If you could give me your responses, then I can plan, like if most of you are familiar, then I can skip the slide and move on. Maybe if there is few responses, maybe I can just quickly show you the demos. Like I can take some sample healthcare data. I can show you how we can analyze it, or how we can build models, kind of that. Okay, I'm going to the Menti. Okay. One, two, here, yes. Open new chapter. Okay. I just want to, yes, this is the one I want to see. So I'm going to present the responses. Okay. Okay, I could see people, one people have given Tableau and 5 have given response to Python. Okay. Okay. Is anyone else? Maybe I can wait for a minute. If anyone would like to give your responses.
Yes, ma'am, they are interested to do that. We will wait for a few more minutes, ma'am.
Okay, ma'am, no worries, no worries. Just wait for a minute and we'll.
One response from chat boxes, we can go with Python. One vote.
Okay, no worries. Okay. All right. I think, yeah. Okay, no worries, ma'am. I think I've got like 7 responses for Python, 1 for Tableau they are familiar with, and 2 none, and 1 others. Okay, I'm taking this one. I'll quickly show you. Um, how I can go with. Just asking me to just.
Many of the participants is requesting go with the Python only, ma'am.
No worries, ma'am. I have Python. So first I will open that one. This Jupyter is here. Now this is Tableau. I can show you Jupyter. This. This one. Okay, I can close this one. Yeah. Jupyter. Yeah. Yes. Okay. So maybe I'll go with their request. For example, what I've got is, for example, how we can do with Python is, for example, I use Jupyter Notebook, and I've just got a a simple data set. I'll just show you how we can literally how we can, for example, if you would like to do some predictive analytics with this diabetics data set, okay, right? If you want to build a model, okay, or either a machine learning or a deep learning model, how we can do that, right, with the Python. And I'm using the platform as a Jupyter Notebook. For example, if you could see, I hope my screen is visible. Okay, I just got the
Yes, ma'am.
the data
Visible
set.
only.
Yes, ma'am. Thank you. So, for example, what I've got is I've got a a data set, the diabetic data set, which you could find it online. Okay. For example, all we usually, maybe if you're familiar with the Python, I'm not going to go deep into the Python because that will take a longer time if I start explaining the script. So I'm just give an outline. Okay. So I'm just importing the required packages. Okay, and then I have I got the diabetics data set. I've just uploaded into my Jupyter. If you have some data set, you can upload it into Jupyter. So I've just uploaded my diabetic data set here. Okay, I've just, I'm just using, I'm just reading that, it's a CSV file. I'm reading that CSV. I'm creating it as a data frame. And then I'm just, running that script. So now the data frame I've got the data which is stored into my data frame. Okay, this is my data, and it has, for example, if there are a lot of features, okay, here there are a lot of features like, number of pregnancies, glucose level, blood pressure, there are more in it. For example, and all these are the input attributes, and the last column is the output attribute. Okay, that's the category, that's the column. Okay, the last column, whether the person is having diabetics or not. Okay, the outcome variable. Okay, right. So this is my data. Okay, for example, sometimes we don't need all the attributes. We call it as like feature selection. No, there are like many standard techniques to do the feature selection, but I'm just doing here for example, I feel like maybe I don't need all the features. Okay, for example, because if I take only the relevant features, and if I feed in, my model will be even more accurate, right? So just keeping that strategy, and what I'm doing is, I have so many attributes, but what I'm doing is I'm just taking these 4 key attributes. Okay, for example, pregnancies, glucose, BMI, and age. Okay, so I'm taking those 4 attributes alone. I'm taking that as my inputs. Okay, just my input attributes. Okay, and then I'm going to predict my outcome variable, whether whether the person is having diabetics or not. Okay, right? So I have imported my file. So just then I need to run the script. Okay, and then my inputs are here. Okay, I just got all from my actual input. I've got only my four features alone. I have just extracted only these 4 features from my actual input. Okay, after getting that input, see if you could see here, right? Because here I'm using the scikit-learn. I'm going I just want to build a simple logistical regression model. Okay, so what we need to do is, for example, when you now I got my data is ready now, right, my training data is ready now. Now what I need to do is I need to build a model, right? So if I want to build a model, right, so for what I need to do is, maybe this could have been covered early. If I'm having my data set, I need to divide my whole data set into training data set and testing data set. Obviously, for example, if I take 80% of data for my training and 20% for training, for example, okay, so the 80% of samples will be sent for training the model, and with the remaining 20% of model, it will be used for testing the model build. Okay, so so like we need to split our, before we build the model, what we need to do is we need to split your data set into training data set and testing data set. Okay, or you can have like two different data set, one for training, one for testing. So that is also you could find in most of the data repositories. Okay, so here I'm just using the same data set. Okay, I'm just if you could see here these two statements, I'm using the trying, these are all like built-in methods. We can just use the method, we just need to pass in the attributes, okay, the parameters. Okay, I'm gonna use this trying test split method. I just, if I pass on my inputs, this my inputs and my outputs of, like this inputs and outputs are my inputs and output values of my training data set. Okay, so I'm just passing, like, no, this is my whole data set. Okay, my whole input, whole output I'm passing, and this method, okay, will split my whole input and output into training data set. Like, no, X train and Y train are the input data set. Okay, similarly X test and Y test are the testing data set. Now my whole data set has been divided into training and testing data set. Okay, X is going to be X train is going to hold all the input attributes of my training data set, and Y train is going to be the output value of my training data set. Okay, right. Similarly, X test and Y test. Okay, X test holds the input attributes of my testing data set, and Y test holds the corresponding output of that testing data set. Okay, so I've just this, so this method will split your training data set and testing data set into two. And then once I split it, let me run this. So once I execute this, now like I use my X train and Y train to train my model. Okay, and then later I use my X test and Y test to test my model. Okay, so now it's executed. I've just splitted the data set into training and testing. Now I'm because, you know, in terms of, because, you know, here this demo I'm not going from the scratch, okay, to show the, because, you know, obviously every algorithm you can develop from the scratch, because every algorithm has its own methodology involved to deal with the data, to work with the data. Here for demo purpose, I'm just showing there are built-in models available. Okay, with every standard packages, there are built-ins available. I'm just going to use the the logistic regression model which is available with the scikit-learn. Okay, right, I'm just going to use that here. Okay, that's what I'm just importing from scikit-learn. I'm importing the logistic regression model. Okay, I'm just creating an instance, and this fit method is used to build your model. Okay, so for this fit, like this is the instance of your logistic regression method. Okay, model, through the instance and through the fit method. For the fit method, you have to pass your training data set. See, I'm passing X train and Y train. So I'm passing these two, my training data sets I'm passing. Now with my training data set, now the model is built. Okay, right? So then after now I build the model. Now now the model is ready now. What I need to do now, I need to do the, I need to test my model, how accurate my model is. So to test that, we have a test data set, right? Like, you know, we have the X test, it includes all the input features of your test data set. So if I supply the input, okay, my model should tell me the, what is the corresponding output, like, you know, whether the person is having diabetics or not. You get a value either 0 or 1, right? It should, your model should do that prediction, right? So if I see, I'm going to see, I have built the model here, this with the fit method. Now the I'm going to use the model to predict the outcome for my testing data set. So that's why, so I'm using like this instance logreg dot predict method, using the predict method, passing the the X test, by passing my input attributes from the test data set. Okay, passing it. If I run it, okay, it shows, see what, so after running the script, what it happens is, so what all the, like, you know, for example, if my test data set has some 20 samples, for example, so I'll get some 20 I'll get a 20 outcomes, right, for those 20 samples, right? So that I'm just like, you know, whatever the, for the 20 samples, whatever the outcome variable is predicted, okay, so those results are get stored into Y predicted class. Okay, this is the Y predicted. These are all the class is predicted by the model. Okay, right? Got. Now the model has predicted the outcome of your testing data. Okay, now we need to check how accurate it is, right? Now, so what we have covered is we got the data, we divided the data into training and testing data set, and you can use the mod. Either you can develop from the scratch or you can use the built-in models. Okay, by importing into your script, and you can build a model. And after building the model, you can do the prediction. And after doing the prediction, now we need to figure out, right, how accurate the model is, right? So for that, you need to check, because we have the actual outcomes, right? We have the actual outcomes, like, for example, this y test, the actual outcomes of your testing data set is available with the y test, right? And you have your model predicted is available at y prediction class, right? So if they both are similar, same, if they like, if the predicted outcome is same as the actual outcome, then your result is accurate, right? Your prediction is correct, right? So we need to check that how accurate it is. So to do that, if you see here, so there are built-in methods available, okay? Like, metrics available. Like, for example, if I want to calculate the accuracy of my model, I just need to call the accuracy score method. I just need to pass and say I'm passing the y test holds the actual output of your testing data set, and I'm passing the predicted output. I'm passing both as parameters to this accuracy score method. Now, if I execute this, did I run this code? Yes, I think that. Let me run this also to do the prediction. And now I'm just running this. See, I got it. So now the accuracy of this particular model is like, it says 78% kind of that. Okay. So this is how we can like evaluate the accuracy of your model. I just got one, I have just showed one. There are many things. Okay. Like, you can use some like confusion matrix. You can use like precision recall, the common performance measures we use, right? Like F score, ROC curve, AUZ, all like whatever you want, you can play with that. Okay. Maybe I'll share the I mean, along with the resources, I'll share this to you, share this to the organizers. Maybe you can play with this one. Okay. So this is how we do generally. So if you want to like, work, if you want to build, if you want to do some predictive analytics, so you can just take the data, take some open source data sets, build models and validate your model, and you can play with that. Okay. To figure out which model, because we need to, not every model will suit every data. Okay. So you need to choose the, because, maybe you need to obviously we do, right? As a researchers, you need to trace back, like, what has happened in the literature, which works good for the particular data. Maybe I can come up with a better model than the existing, right? So we can do all that, our stuffs in our, like, work. So so that's how it is. So this is how we can make use of, like, there's algorithm, like, machine learning, deep learning algorithms. You can build any model. Okay, there are family of algorithms, right? So you can use any model, any algorithm to do your predictive analytics. Okay. So so that is about it. And maybe if it is like, if you are for example, if you would like to do some predictive analytics, you can go for this one. Maybe if you want to discover some basic insights about from the data, maybe you can go with like, the tools like Tableau or Power BI. If I can, maybe for example, do I have that? I can, let me, I can quickly, I have less time. Do I have time, ma'am, to show the Tableau, or can I move on?
Ma'am, we have 10 more minutes, ma'am.
Oh, we
If
have
possible,
10
within
more
that, you
minutes.
can
Okay, fine. No worries.
again.
Okay. Okay, no worries. So maybe, so like, no, maybe say Tableau things, maybe you can, I can share the relevant links in the slide. So all you can do is, for example, you just need to, like, drag and drop. Maybe if you give me a minute, because that will might be helpful for many people, maybe who are in the early stage. It'll take, I'll try to quickly show you. I'm not going to take much time. Um, because if you sometimes if you would like to get some, if you have some data and if you would like to get some basic insights, you can go with the like Tableau or Power BI stuffs. Okay, it's taking some time. Maybe if it comes, maybe I'll show you if I get some time. Okay, because in terms of Tableau and Power BI, all that you because you can import your data set and all you don't need to do any scripting like how we do in the Python. You just need to drag and drop your attributes and the measures. Okay, you can create visualizations out of your data. Okay, so that is what is so. If it launches, I will show you. It takes some time to get. Okay, oh, it's opened here, right? So I just opened the Tableau desktop here. For example, if I have some data set, I just got some simple data set. Okay, you can import your data set. For example, if you have a TB burden country-wise data set, okay? So you can import your data set. If you might have an in Excel or a CSV. Okay, I have to import it. It's a text file I have, so I have to import a text file. So when I do that, so all you can do is you can import your your data here, and then what you can do is you can create dashboards. For example, this is a data set contains country wise the instance of TB. For example, if I say for example, if all you need to do is this is your row column shells. You just need to drag and drop. I'll just show you one example. For example, if I have country. Different countries here. Maybe country, we'll take the country. And for example, if I want to know the country-wise estimated incidence of TB, right? For example, I just drag and drop. See, I got the insights, right? So I got the visualization like that. Okay. So all if you would like to just understand some if you want to get some basic insights about your data set. So this visualization says the among estimated estimated TB instance in the across the countries, right? So like that. So if you want to play with your data, if you want to get some basic insights, so you can use have used Tableau here. You can use Tableau, Power BI. These data visualization tools will help you to get some basic insights. Okay, so this is also a tool really used with the healthcare data analytics. So to get some basic visualizations. Okay, and let me go to the slide to conclude it. All right, so just closing this. Okay. Okay, and I'm gonna continue this one. All right, so these are all the tools most widely used. Okay, and and obviously it helps when we use these these AI technologies and all that. Okay, when we need to deal with the data, it really helps. We can do the predictive analytics. It helps the clinical experts, right? Doctors, healthcare practitioners. It helps people. All that, it's fine. These are all the benefits, right? But when I say since we have the time is less, I'm concluding because the benefits are more. But when I say, because there are also some challenges exist. Okay, because when we deal with the healthcare data, right? So these are all the challenges. Maybe some of the challenges could have been covered earlier, that because we deal with the healthcare data, people's healthcare data, right? So the data privacy and security, it is very important. So how we're going to deal with that. Obviously taking the anonymized versions of the data and going forward, and taking appropriate ethical approval processes, and following the the Data Protection Act guidelines like GDPR and all that. So we need to go with follow the regulatory compliance, right? So all that would really help in sorting out the privacy and security related challenges. So that is one thing. And also hello.
Sorry, ma'am.
So
Sorry.
also data integration, because because we are moving from earlier we were using only one modality for diagnosing the diseases, but over time, we are moving towards multimodal data, right? Because we need a CT, for example, we need a healthcare record, and we maybe we need to rely on multimodal data, like to come up with more accurate predictions, right? So now, how are we going to integrate these multimodal data? So that is also a challenge, the data integration. Maybe the advanced big data platforms are helping us really to do that, right? So data integration is a challenge, and as we discussed, bias and bias in the data set, and bringing the fairness in the data set would help in sorting out the biasing issue, kind of that, and integrating it with the clinical workflows, because this is one of the main challenge. Because as researchers, we do a lot of innovative we can design, develop tools, but what we need to keep in mind is, before we start our work, how how, for example, how are we going to integrate this particular tool into the clinical workflow? What is already there in the current context, in the current system, what is needed? So then maybe you can develop a customized tool, for example, a diagnostic tool, which could be integrated into the clinical workflow. So because otherwise, if we don't consider the current context, and if we just rely on the literature, and if we build something by ourselves, then will not be able to integrate that into the clinical workflow. If we cannot integrate into the clinical workflow, obviously, clinical practitioners or healthcare practitioners cannot use it, and that's not going to help the people. I think this is one important thing every researchers, as researchers, we all of us should consider this, and we should start our journey towards developing solutions for the for improving the population health and the patient outcomes. Okay, so these are all the challenges. Yeah, I think a couple of things have added up along with that, because because always also there is a thing, the lack of trust is also, I would say, one of the main challenge. But obviously the AI cannot replace human, but the human AI can aid or support a human intelligence, right? Like kind of that. So it could be used as a support system. Okay, kind of that. So because this lack of trust in the AI algorithms also, because how far because that's there, right? Because how far the accurate, how far we can believe the algorithm, right? So that also matters. So we cannot replace the doctors with the AI tools, right? So that is also one challenge. So how we can sort out this? Maybe if we could come up with a more trustworthy AI models. Okay, so maybe then that trustworthiness, how we can bring the trustworthy AI model is obviously bring the fairness, right, and bring that integrity and everything, and the diversity and everything. If you're doing all this stuff, maybe that would help us to come up with the trustworthy AI model, and maybe that would help in sorting out these challenges. Maybe for example, like how, because the World Health Organization released how, for example, how AI could be used in in healthcare product development solutions, so they have shared some guidelines around, okay, how we have to go with it should protecting the human autonomy is important, okay, and human well-being is important, safety of the public, all this, and whatever we do, it should be transparent, and we should take the whoever we develop, right, take the responsibility and the accountability, and we should ensure the inclusiveness and the equity, what I mentioned, right? And we should build a responsibility, and the responsible. Now we have many more technologies around, from emerging from AI, right? Like responsible AI, ethical AI. So building building a trustworthy, responsible, ethical AI, right, would help in addressing the challenges, right? So that's the point I would say. So maybe maybe just to to move forward, maybe as researchers we can explore we can explore explore and move forward towards the proposed area, and maybe these are some future areas around how it moves forward. It moves towards multi-modality, and most of the work's going towards real-time monitoring with the AI, wearable mobile health technology. We can come up with there's a lot of potential scope and opportunities towards that, okay, to do the predictive analytics, and maybe as towards R&D, research and collaborative works. Maybe we can explore the emerging areas in the proposed area, like AI, big data, healthcare, and we can explore the opportunities for collaboration. As I mentioned, collaborating with the healthcare people, healthcare practitioners, or the healthcare organizations, hospitals, right? And making that collaboration, and then maybe we as a researchers in collaboration with the healthcare organization, so we can jointly apply it for the funding so that we can really serve the need. Okay, so that would be the way forward for towards doing the carrying out our R&D works with the potential collaborations. Okay, so and in terms of the data set, maybe this has been covered maybe by the earlier experts also. So there are a lot of data sets available. Okay, because for example, Figshare is one data set where you could find a lot of data sets. Okay, like the knowledge KD Nuggets is another data set for data science, machine learning. Okay, and United Nations data set. Okay, and UZI, I think this is one of the commonly used. UZI machine learning. Kaggle is also used for very like early seed works, right? And then the UK Biobank, it has voluminous amount of data, the UK Biobank. And there are data, for example, if you want to do some data visualization works, maybe the Tableau itself has a lot of sample data. The one I showed is the TV data that's from the Tableau portal. I got it. And also Amazon Web Services also giving some public data, and there are a lot of health related data sets are available, healthcare related. And Data Hub, okay, there are a lot of data sets are there. So as I mentioned, you need to explore and figure out and get the right data. Okay, so so that's it from me. Okay, I'm now looking forward for any open discussions or questions around the topic.
Thank
Yeah,
you so much, ma'am. Thank you for giving
yeah,
your wonderful session in AI and big data analytics, particularly how to handle the data with the AI. We have
yeah,
given it is a great insights to the beginners and also those who are all pursuing the research. In case of a predictive analysis and also the in medical field, how we can proceed with the existing data sets which is available in the open source. I
yeah.
think you have given great insights to the participants. And one few questions that they have
Yes, ma'am.
given in the chat
Yes,
box that I will
yeah,
read now.
yes.
Tableau versus Python, which is the best tool? This
Mm-hmm.
will be the one question
Okay.
asked
So
by
I
the
would say for
students.
sorry, yeah, yes, ma'am. So I would say, for example, if we are, because Tableau, it because it helps if you would like to gather some basic status, if you would like to get some statistical insights about your data, you can go for Tableau. And because now, because the Tableau is emerging, because we have a Tableau desktop, and mostly it supports structured data. Now it's evolving actually, because now only they are coming up with the, the Tableau, because they're coming up more with more customized packages. But I would say, if our data is completely unstructured, I would recommend that we have to rely on the the platforms like where we can use Python to make our to build our machine learning model. So if it is a structured, I would recommend the Tableau to get the basic insights. If your data is unstructured, we have to go with Python. Yeah.
One more question.
Yes, ma'am.
Pneumonia diagnosis, any benchmark data sets? Please suggest. They are asking for your suggestion.
Pneumonia data set. Right now, I don't have any specific link, but where you can search is, um,
You have given more number of data
yes,
sets
maybe the
in the
UK,
states.
yes, ma'am. So maybe the UK Biobank is one data set where you could, I think they have covered you could find, most of the disease has, I mean, the data set has been covered across the different wide variety of diseases. Maybe I would suggest maybe they can check with the UK Biobank is one very good source, and also the Figshare also they can check. Maybe I can also check, maybe if possible I can check, and or maybe I can add along with my slide. I can send it to you if there is something, a specific source for it. But they can find it in the, maybe they can check for now. I mean, maybe they can check in the UK Biobank and Figshare, I would say. Yeah.
In Indian researchers, there will be the great challenges getting the data sets, real-time data sets getting a challenges. That is why they are
Yes.
looking for the data sets from the other country. For
Yes.
validation purpose, we need data sets from the other country. It is useful. That's the thing. The
Yes.
participants is raising the questions, and the
Yes.
question is, ma'am, from where can I get the breast cancer data set with
Mm-hmm.
stages of breast cancer?
Mm-hmm. That's what.
For
So even I
imaging,
have,
ma'am, imaging breast
yeah,
cancer imaging
yeah.
analysis they were.
Yes. So maybe I think I've seen, I'm not sure, but I can double check for you. IEEE data port, that is also, I would say, one of the good repository. Maybe you can in the UCA learning repository also. I've seen some couple of imaging modality data sets. So you can check UCA machine learning repository. If you would like to do some basic seed works on imaging or ECG, you can check with UCI Kaggle, or you can also check in, because I have seen some data sets with IEEE data port. You just need to sign in and you can get the access. Okay, so IEEE data port is also another good source of, I would say, data. I know if you would like, if you're looking for blood cancer or heart disease or lung, anything. So maybe these are all the sources. Any other yeah, for now this is what it comes to my mind. Maybe I can maybe take some time today for you. I will try to, I have added a couple of links which I'm using it already. Maybe I'll explore a few more links for you towards your customized queries, and I'll update, and maybe I can send you that. Okay.
Yes,
Yes,
ma'am. And
so
also, yes,
yes,
ma'am.
ma'am.
Ma'am, you want to tell something? Otherwise,
Yeah,
I'll.
because there was a chat in the question, like, no, how to approach a hospital. I
Yes,
could see that.
yes,
Is that,
yes,
ma'am? Yeah,
yes,
because obviously how, because there is no template, or I would say procedure. For example, if for example, if we are a researcher, or if you are doing our research, maybe no, maybe under our, like, no, with our supervisor's support, maybe we can approach a hospital and we can say we are doing our research and this is our work, this is what we would like to do. And maybe no, with the formal, maybe they sometimes they'll ask for, like, no, just to check the authenticity, they'll ask for a letter from the university, right, wherever we do. So with that letter of support, maybe we could reach out to the hospitals, and I'm sure they'll be able to support you, because if they have the requirement. Sometimes I would also suggest, like, when we are identifying the problem statements for our research works, for our scholars, maybe we can jointly do it, as I mentioned, like, you can sit with the the healthcare team and practitioners team, and you can jointly come up with an requirement, and further, so that they'll be able to feed in the right data. So that would be helpful for you to move on. Yeah, I think that's the way for
sure.
researchers. And I think for, like, when we do research projects, I think that's we just go with the, like, we have to just make a NDA between the university and the hospital, the non-disclosure agreements and all. We need to just sign up the agreements, and so that we both, like, hospital and the university can work together, and we can jointly submit funding applications. Yeah, to carry out the research with the funding support if we need some. Yeah.
Regarding data sets only, we are getting more questions. Any
No
data
worries, ma'am.
set?
If you
Yes,
could
ma'am.
just, if you could share, I'm not sure whether I can access the chat,
You
or
can
if you
access,
could
ma'am.
just send me the data set related questions.
Questions.
What I can do is I can just take some time. I can take some time and I can maybe explore, get some relevant links, update in this existing slide. I can send it to you in a daytime, kind of that.
Yes, ma'am. Sure,
Is that all
sure.
right, ma'am? No
Yes, ma'am.
worries, ma'am. Yeah,
Yes,
but
ma'am.
there are data sets. Yeah, we'll be able to, like, not to do this, to start with the state works, ma'am. Yeah, I'll try my level best to get the more relevant links and share it along with the slides.
Sure, ma'am. I will share the questions to your mail.
Yes, you can send me, ma'am. Yes, you can
Yes,
send me
ma'am.
the list of questions relevant to the data set. I'll take some time, maybe 1 or 2 days time, and I'll get back to you by this week. Yeah.
Sure, ma'am. It is a wonderful session and it is a nice time. I am you have shared your valuable session with us. Thank you so much. And also, in future is also we need your support for our research work, and also for an upcoming our events. Also, we need your support. Thank you. Thanks a lot, ma'am.
Yeah, thank you. Thank you so much, ma'am. I mean, it's really a great pleasure being a part of your Atal FDP session, and thank you for inviting me to be a part of this. Atal FDP program, and looking forward, we're looking forward for future collaborations too. And if anyone would like to, connect with me, I'm available in LinkedIn. Maybe I can just share my link in the
You can
chat.
access the chat box also, ma'am. You can give
Yeah.
your LinkedIn ID if possible.
Yeah, yes, ma'am. I can give my LinkedIn. Just a minute, ma'am, so that you can connect with me if you would like to have a chat towards your research works, any collaborations. I'm looking forward. You can connect with me. Um, just going to my I'm just sharing my. Yeah, I'm just sharing my LinkedIn. I shared my LinkedIn profile link, ma'am. So if
Yes, ma'am.
anyone would like to have a chat about your research works, any collaborations, I'm looking forward. So
Thank you, ma'am.
Thank you so much
Thank you so
for
much.
the amazing opportunity. Thank you all, and it's nice to be here. Because I know the timing is different from here to there, and it's very late. And I really appreciate all the participants and staying active till the end of the session, which is not easy after working time, right? So I really appreciate that. There is a hand raised from Ashwin, ma'am.
Ashwin. Yes, ma'am. Just a
It's
minute.
a
I will
question or is it by mistake?
embrace.
I'm not sure. All right, ma'am. Is there any other questions, ma'am? Can I? All right.
No, no, no question. And
All right,
regarding
ma'am.
the
All right
research
then.
only, I will
All right. You
consolidate
can send
every
me an
question
email.
and I
Yeah,
will
I'm
send
looking
you.
forward. Yeah, I can update and send you the along with the slides. Yes.
Sure, ma'am. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you so
Yes,
much for the opportunity. Thank you.
yes, ma'am.
Thank
Participants, I
you.
have posted the feedback link in the chat box, and also I will be the meet will be stay on in this for next 10 minutes. You will use the feedback link to fill your feedbacks, and also I will get back to you after getting all the questions with the Priyadarshini ma'am, and revert the PPT to the all the participants at the end of the session. That is at the end of Atal Fdp. After sixth day, I will share with you.